Okay. I suppose we can get started for today. It's 8:36. Thanks anyone who is here for tuning in. Today is like I guess our demo day for like interview Android job search week. And so today we'll be doing a like a mock interview question for like a pretty difficult Jetpack Compose like state MVVM kind of question. But before we get into that, we have some announcements. Um, for a hack challenge timeline, you might have seen an email that like I posted a CMS assignment. That's not for you to submit, so don't worry about that. The final hack challenge submission is like just on a Google form, and that's due on like Friday, end of the day, like midnight. And so don't worry about submitting that on CMS. Um, as for A6, that's due after the hack challenge. In fact, you don't really have to start it at all until after the hack challenge. It should be pretty quick, especially if you're doing retrofit stuff for your hack challenge. You more or less just like bring over your retrofit stuff, and then it's like kind of the same. And yeah, overall, pretty simple assignments. So hopefully it doesn't take too long, and that'll be due Monday. And do not come to class Monday because there is no class. This is the last intro to Android class. So if that's all sounds good, let's go into the interview question-ish for today. This is just kind of a question that I sort of made up, but at least it starts um, demanding a little bit more like difficult MVVM state management and like logic stuff, which is, or at least something that MVVM is like really good at handling. This is what I'd like to call like the entropy rows, which we'll get into the problem statement of it into, or it like into the problem statement right now. So actually, first thing I'll do is just show you a demo of kind of what we're expecting alongside the alongside like the question. But the question is here just on the textbook. And we can quickly kind of go over what we have here. So um, for some quick rundown information, this question, although we'll give you, or although I'll probably take about 30 minutes to solve it just because like of like the time constraints here. A question like this would probably be meant to be completed like with your interviewer, like asking them questions back and forth and whatnot in like a 60-minute time slot rather than like a 50 or like 30 minutes that I'll use to like go over it very quickly. As some other information, like to like after you've been given a question like this, you can usually use like internet searches and whatnot. Mine is just like ChatGPTing the question to complete the task. And this question in particular goes, or it's for Jetpack Compose, and it's like particularly about state management and like composition lifecycle stuff. You might also encounter questions about these other topics like networking, concurrency, just like, oh, how well can you build UI, stuff like that. But those aren't tested in this question. It's mainly just like state management, app logic stuff, which I think is a good serves as like a good test to like, oh, how well do you actually know Java Compose? And those other ones are good for like how practically have you built an app in Compose as well. But going into the problem statement. Uh, so the general app you'll be making, which is not actually very useful of an app, is this like one simple screen that just has like these couple bits of information. For some reason, this keeps saying there's a message. There we go. That just has like these little uh, three rows, if you will. The sort of main thing about these rows that makes this problem kind of difficult is that you can theoretically just kind of keep scrolling on them forever. Not like literally forever, but more or less forever. And like you would never hit the end, you would just kind of keep scrolling. And the idea is as you keep scrolling between like these three different rows, the little entropy value on the top increases. I guess just to add like a little bit of extra complexity, the idea is that like you would pick a number around this entropy value so you can see as you're scrolling. This is like around at this point 147,000, I guess. And the numbers that are spawning here are like around that number. And as you sample numbers in these rows, you'll see that the items that you scroll on in these rows sort of sample from this like random entropy value. So there's a more succinct or like detailed thing breakdown of your requirements. So at the very top, you'll just have this like this little these two labels for just like the entry value and the most recent entry value. That's not too important. The main like requirement, I suppose, is like the infinite row. And first, you'll be focusing on trying to make one infinite row. So let's go over the requirements of this really quickly. So in order to build one of these rows, what you'll want to be doing is have like an infinite scroll. You shouldn't be able to like realistically hit the end of the scroll, only have like 20, 30 items or something. It should just keep on going. Um, each entry in the row will just be very simple. This is literally just like a surface with like a number in it, nothing crazy. Um, and whenever you scroll, like the act of scrolling and like sort of rendering a new entry in the row, should sort of like spawn or like sample a new value and put it into the row or like I guess like effectively put it in that row as you're scrolling. So you can see here that when you're scrolling, the entry value like goes up here, and then those random values get sampled and like put into the row here. So as you scroll on new entries, scroll through these rows, this entry value gets like sampled from, which is just like plus 100 or minus 100 from that entry value. You put that value, like you sample that value, put it into the uh, row like text, and then the entry value should then like increase by 1,000 every time you sample a new one. Um, And I guess the general idea is that as you sort of spawn new entries, as you scroll and spawn new entries every single time a new one appears, scrolling back won't do anything. It's only sort of the act of spawning a new row by scrolling in some sense, that this like sampling process will occur, and the entropy will increase by 1,000, if that makes sense. I know that's kind of like arbitrary with the entropy stuff, but I wanted to give it at least some sort of grounded basis. But yeah, the general idea is as you scroll, these entropy values will be like sampled from one by one by one. And the idea is that you could just keep on scrolling, that you would not affect or that you would not realistically hit the end of it. Okay. And then like as a guess of as a challenge that is in terms of implementation, like in terms of yeah, in terms of implementation, as long as you've done it like correctly with MVVM, shouldn't actually be that difficult, but this is a requirement that kind of makes it like, yeah, you should really be using MVVM for this. Is just this where yeah, we want to use or we want to be able to have like several, like multiple of these rows that as you sample, they will all sample from the same like total entropy value. And so you can see here, even though I scroll from the middle one, the entropy value goes up to like 124,000. Now you can see here as I scroll on the bottom. Let me see if I can get that back. Yeah, you can see here from the bottom, it will start sampling from that entry value as I scroll the row 3, even though it was at like 20,000 before, roughly, if that makes sense. Okay. So I know the requirements there are like a little random-ish, but when it comes to these state management questions, they rarely have like a or they don't necessarily have like a completely grounded like, oh, we're making an app that solves the problem and looks really pretty and stuff. It just kind of is like random stuff like this, like do you know how to use states and MVVM and stuff to do this like really random thing. And so yeah, that's more or less the problem statement. Does anybody have questions about like what's going on in this problem, how or at least like what you're expected to make? Any questions about that? Yes, we have something in the chat. Um, oh yeah, yes, we will code this together, and I guess we'll also give you like a little bit of time to code this like on your own in a bit or like for a bit if you would like to like try to get a little bit of this stuff set up and working. Because once I start going through it, I'll probably just like go pretty fast. But yeah, we will actually be coding this. And as I go like step by step, I'll be explaining what to do, and probably also to your interviewer if you were doing this as an actual interview question, you'd want to like start off by like, explaining like your general thoughts or whatever. But indeed, you would actually want to actually make this and like run it on your emulator and show your interviewer that it's working and stuff like that. Okay, awesome. Any other questions about the problem statement here? Okay. If not, then we'll give you a little bit of time to just sort of take a stab at it yourself. Just sort of think about it for a little bit. See if you can come up with like any questions or just like sort of read through the problem statement a few more times to see if there's anything else you're sort of missing. And then I suppose, let's see, that's uh, I think at, what did I say? 15 minutes at 8:50, which is like literally in 3 minutes or whatever. I will start going through like a walkthrough and talking through it and whatnot. But you can take a few minutes here just to sort of go over the problem, what you would do, or at least start thinking about how you would start tackling this, perhaps with MVVM in mind. But there are definitely some like tips and tricks for this particular problem that uh, we'll like go over that are pretty key to making like infinite scrolling and rendering and stuff like that. But regardless, we'll give you a little bit of time on your own just to think about the problem. And we'll be back in a few minutes. Okay. I suppose we can start discussing how to perhaps approach this problem. So the idea with this kind of question, where you're basically given no context and just build like a random app, is that you'll just build it from a completely empty activity. oftentimes on your own machine, and just like you'll just screen share it like to your interviewer or whatever. So you're literally given no code, like no starter code or like anything, and you're just asked to like make this thing. In general, some tips I would like to give in a context like this, which is not like entirely always the case. Like I think it's very possible that you will get release code on like Android interviews. I think it's possible anyways. But at least for this, you're not given any release code. And so yeah, so some tips as to like how to save some time. You'll know that throughout the course and throughout the release codes we've been giving you, generally stuff like view models and whatnot are set up already with like Hilt and a bunch of dependencies. When it comes to like just such a simple app like this, oftentimes you can forego a lot of those like best practices things in favor of something that's just like really quick, like, oh, let me just put this class down so that like I can just build this thing. Um, and I don't really care about best practices. So, for example, if I wanted to make a view model, I could just call it something like main view model. And instead of annotating it as like a hilt view model or anything like that, I'm just going to call it like view model. To be honest, I'm not actually completely sure if this does anything or if it would be fine if I just literally didn't call it anything. Oops, let me turn off my autocomplete again. But yeah, to be honest, not sure if that entirely does anything, but at least it like looks like it's annotated as a view model. Then that basically is like subtyping in Kotlin, but um like inheriting. But like that's all you need to do. And then if I wanted to build that in my main activity, like there are libraries you can import and stuff to like make a view model for you, like view model factory things or whatever. And those are definitely best practice. But if you're just doing a little interview like this, so you don't have to care, you can just say like you can literally just construct it like you would any other object, just throw it here. Um, and you can then use your view model. This would probably be sus if you had like navigation and stuff and need to care about like when view models get like built or like constructed and when they get like deconstructed and stuff like that. But if we're just in this like one app activity, then we can just do this and not really care about the fact that that's not best practice. Something else we can also do is just go ahead, I'll build this in the meantime. Something else we can do in the meantime is, well, if we know we're going to be working in these two files, I'm just going to work like this, split these two files like half and half so I can just work on them at the same time. And instead of like making a bunch of different files for all of my composables and like UI components and stuff, which would definitely be best practice. Oops, I should probably make this a little bigger. Instead of like making a bunch of files and whatnot, I can just what do you call it? Just put everything sort of in this one file for like UI and then in this other file for a view model. And so, for example, if I wanted to make a screen, I can just make it here. Main screen, have that take in my view model. Yeah, main view model. And like instead of, I just put it here instead of putting it in its own file, just to again save some time. Okay, so just to get started, it's still a good idea to like organize your code in general into like components and stuff just to make it more readable. And so for example, if we're going to try to build our header here that has this like entropy value and most recent entropy value, we can do that. So we can call that something like entropy header. And so this is just sort of laying the groundwork for at least the UI, and then we'll talk about obviously the more difficult stuff with like the rows and whatnot. But for now, this entropy header takes in like two parameters: the entropy value that changes over time, as well as the like most recent one that has been sampled and put into a row. And so we can do both of those. So it's just an integer, and then like most recent sample also an int. And yeah, the UI here looks pretty simple. Not that you'd have to like replicate it exactly. That's definitely not a big point. But something like entropy value. And oh, oops, this is kind of annoying. One thing, if your uh, compose things aren't importing, this started happening to me for some reason. Instead of hitting like enter, you can hit tab whenever you're like selecting one of these, and it'll like import it automatically as well. Sometimes the import like doesn't work It just popped up again. That's weird, but yeah, that also like imports it at the same time as you like inserts the line of code, which is nice. But we can make this like horizontally, center horizontally. Um, have like a bigger text here for the entropy value that's currently being rendered. Again, this is just like pretty random basic UI stuff. Say this is a little larger. Um, maybe put like some space here. So modifier dot height. A spacer like is basically just something that takes up space and like doesn't render anything actually. So we'll just make it takes up some space and then have this final text here, make it a little smaller, and have it just be this most recent sample instead. Um, and so yeah, this is just going to serve as like a way for us to render the header here. So that would again just be like the entropy value, the value here, and then the most recent thing. And so that's just like some UI that we built pretty quickly. It's good to be able to build UI quickly and like know like, oh, just make something centered horizontally, you have to use this argument, for example. And that stuff just comes with practice. And so if we're going to build our screen, in general, we'll use like the same kind of setup with like a column. We might want to make this fill the entire screen since it's the whole screen. So we'll use fill max size and also center horizontally again. Something like a good coding tip in general with IDEs. You can see here that if I want like center horizontally, I can just type in like CH for like C, like center horizontally, like C for center, H for horizontally, and it'll like auto-complete it since like IDs are pretty nice, pretty smart. So I don't have to type out the entire thing. Um, and let's see. So this is the entire screen. So now I'm going to say, you can see here that there's some like big spaces in the UI, which are all like kind of even. If you just want to do something like that, that's kind of slapstick, you can use instead of height, you can use modifier dot weight on a spacer, and then they'll sort of like expand to take up as much space as possible. So if you put in like three of these, for example, they'll all like evenly divide the space. And so I can put some space, put my header with, we'll have to make the entropy values in a second, but then also like the infinite rows stuff here. Okay, so then this is like the basic layout of our screen made pretty quickly. Let's see, we got 25 minutes or so. That's good. Okay, so this is like the basic setup of the screen, nothing too crazy. We're just sort of structuring our UI. And so now we can start considering at least like how to use our view model and how we're going to like tackle the infinite row stuff. So at the very least, we can put in some more code for this main view model since it's a little bare bones right now. You don't necessarily have to make like a proper UI state class since that's kind of like technically kind of like boilerplate unnecessary code, but I think it's still good to make one just because it's like good organizational practice. And so let's see. In terms of the state that the screen needs, we'll need like an entropy value, most recent entropy value, of course, since that's what the header needs. And so we can add stuff like that. Oops, obviously that's supposed to be capital. Okay. And then we can start talking about the infinite rows in a second, but we'll also need to make a UI state flow. And you could like you probably saw in some of the release code that we had like a UI state flow that was private, one that was like public, that was a regular state flow. Yeah, like if you're making quick code like this, you don't have to bother about little nitpick code practices like that. You can just like use the mutable state flow. Like a lot of this stuff is just about like saving time, just being like, and like speaking through it, being like, oh, I could do this. I know that this is probably not best practice, but I'm just gonna save time. Saying that stuff to an interviewer is also good. But we can put it in default values. So let's say just like 0 for default value and most recent, maybe just something like -1. I'm sure they don't care about. Oops, I pressed my AI button on my Windows laptop. I mean, I'm sure they don't care about like the specifics of like edge case behavior and stuff like that, unless they ask for it. But um, in any case, this is a good way for our view model to now give our UI like state updates. So we'll just pull that out. Again, this is just stuff we've learned. about like MVVM in the course. So dot UI state flow dot collect as state dot value. And now UI state is just of type this like UI state class we made. And so the view model will now tell the header, you should use this entropy, and you should use this most recent entropy. Okay, cool. And so technically now that's like our entropy header. Theoretically, we should be able to run this, and then we'll see how it goes. I already implemented it before, so that's uh that's what's on there now. But this will rerun in a second. Okay. And so now like there won't be any infinite row stuff going on, but at least this is just like the very basic and nothing is rendering. Oh, because I didn't call it. Main screen, you still need to call that in your main activity since this is where like your app actually runs from. So if you don't call anything, nothing's gonna render. Let's place the main screen there. So now it should render at least just the header and well, nothing else because we didn't code anything else, but let's see about that. Okay, cool. Oops, that just says -1. We should probably say most recent entropy value. Okay, cool. And maybe give this some more space. Like the specifics about spacing and stuff, that's definitely not something they would care about. In something like a UI interview, they might give you like a Figma design or something, tell you to try to replicate this. I don't know if they would actually tell you to do that or if that's like a common style of interview, but at least certainly not for this. Like they wouldn't tell you like, oh, this they use 60 UDP instead of 50. Like they don't care. They at least want to see that you make the screen like somewhat similar to what they were expecting, just vaguely similar. But okay, so now we have our UI and our view model set up. And so at least so far, it's kind of like arbitrary, like why did we even make a view model? But certainly for this infinite row stuff, like when the actual sort of logic starts to get kind of complicated, a little jumbled and whatnot, then the view model definitely comes in handy. So, or in terms of like running and handling our app logic for us. So, to make an infinite row, here's like I guess trick number one-ish. So I guess there are a couple of ways that you could like sort of like custom make an infinite row in some way of like, oh, as you scroll, you keep adding elements to the list that's rendering it, something like that. But one way you can like very easily make just like an infinite row is just with a lazy row. And so you know how there was like one slide in the earlier stages of this course when we said that like lazy column, lazy row only renders like technically the a couple of elements that are on the screen. And then any elements that are not on the screen just sort of get recycled out and unrendered. So even if you were to like render a crap ton of elements, there would only ever be like 7 actually being rendered on the screen at a time. And so what that means is that if we just pass in like a massive number here, like in .max value, which is like more or less infinite, that's what we'll say like infinite is because you should never realistically be able to hit the end of that. This isn't really like, oh, I'm going to render 2 billion items. It's more just like I'm going to render only 7 items because this is like a lazy row. And so computationally, it'll still be fine in terms of rendering. But as you scroll, the like parameter here, which we'll call I, is like, oh, you should be rendering the ith element at whatever scroll you're at. So this is kind of the like a little bit of a cheat code of how to make infinite row like pretty easy, just like how to make you able to scroll for forever. Obviously, though, in terms of like our data, like our main view model, we can't really just have like or I guess like the idea is that we wouldn't want to have just like 2 billion size list because that seems kind of bad. And so we'll definitely want to think about a more like practical scenario or practical situation of how to do that for our UI state instead of just making like a literal 2 billion size list, which again is a little sus. But at least for our lazy row, like in terms of the UI logic, we can just do that. Okay. One thing also that we'll probably want to do when it comes to making our row is to make like make a little component for this, just to make, again, things a little bit simpler. So we'll just call this like a row entry. In terms of rendering, we'll just need to know what number to put here. So we'll just say num. And this is pretty simple. Again, like you don't have to worry about the specifics. I'm just going to make it look kind of nice. Oops, let me use tab. Surface. Let me make this a rounded corner shape of like some size. Give it some shadow and maybe make it like background white, although I think it's already although it's already a white background by default. Then we can give it a little text here, very simple. Just copy a text here. Put in the number and maybe lower the font size. And we can like make it a little easier to see just by giving it some padding around it. Okay, yeah, very simple little like element here just for the row entry, just so that like we don't have to write a ton of code inside of this like items bound. We just like call row entry. And so at least the idea here is that we want to call row entry on like whatever item is present in like index I that the view model says. So when it comes to MVVM in general, and this is why the view model starts becoming kind of useful for us, the view model is in charge at all times of telling the UI like any state that's on the screen. And so um, although it's kind of difficult for you to say like when you're building the UI immediately like, oh, how do I build this infinite row logic? How does any of this work with the scrolling and blah blah blah? Well, it's becomes a little bit easier when you think about MVVM because um, the idea is that the UI will just listen to the view model to tell it what numbers go where, and it'll just sort of trust that. And so all we need to do in order to like correctly implement the UI is to just have some way for the view model to tell the screen that, oh, these numbers should go here. And then you decide like the logic of how that works later in the view model. But for now, we can just say that like let's say that we're only implementing one list right now. We'll just say infinite row. And let's say since we only really render like a finite number of elements at once. Technically, like these elements only spawn as we scroll, and so we'll use a like a regular list of int and initialize that as infinite row. And the idea is that sort of as we keep scrolling through this list, um, the infinite row here will be populated with like the correct entries, and then the screen will just say like, oh, I'm just going to trust infinite row to tell me what should go here. So num would just listen to that and say infinite row, at least just for like type safety, to be safe, we can say like get or null and put like -1 or something if it doesn't work. But now the UI is pretty much like, or it's like almost complete. And now it's just sort of up to the view model to determine, okay, the infinite row should update with like whatever rules to then implement this like weird infinite scrolling logic. So, um, so let's see. So in order to do that, we can use like this next trick. So the idea is that obviously it's kind of difficult in Jetpack Compose to determine like, oh, as I'm scrolling, new items are being rendered. How does that exactly work? One trick that you can use when it comes to like that, when it comes to like, oh, knowing when an item has been rendered or like firing some function a when some like UI element has been rendered is with this like thing we kind of grazed over launched effect. The idea is, again, with launched effect, that whatever value you put in here, like whenever that changes, the launched effect will fire. But if you just put in unit, which is kind of like void, it's kind of like null-ish, like nothing, it will just fire once. Basically, fire once when that component renders, and then never again until you unrender and then re-render that component again. So this is a way for us to say that like, oh, row entry I has been just been scrolled on. So we can say like on render and like have us be able to call some sort of function here. And so now on render, again, this might seem like, oh, what do we do to implement this? Well, at least we are using MVVM, and so the UI doesn't have to care about this. Only the view model has to care. So we'll say that the view model will react to, like row item I rendering. And then again, for the UI, all I have to do is say like, oh, okay, well, I don't know what I'm going to do in the UI, but I'll just tell my view model that the row at I has been just rendered. Okay. Um, and so again, so now even though we have like kind of complex like UI code and compose stuff, what is again nice about all of this is that I don't have to really care about any of that when I'm in my view model. I just kind of code like a regular person, like a regular coder doing like regular CS stuff when it comes to my view model, which makes this problem a lot easier to sort of digest and work through. So um, the idea with this like infinite row again is that as we scroll, we will populate new items into the infinite row like as necessary. Um, and so there's going to be some like kind of strange logic, but I'll like work through it. So the idea is that index I might not exist in the infinite row like field there yet because it just starts out like it's actually a finite row and it just sort of populates as we scroll, as this gets called, like new items get added to it. So if I doesn't already exist in the row, let's make it say that it does exist. Yeah. In general, I'm pretty sure this would just naturally get called sequentially, like on row renderer 0, 1, then 2, then 3, then 4, unless you scroll like extremely fast. But let's just assume you're not going to do that because that'd be a little annoying. So if uh I is like index I is not in the list or whatever, which is just going to be what if it's greater than or equal to I have to get the infinite row first from the UI state. I can get that with UI state dot value dot infinite row. If the index you just scrolled on is greater than the row size, meaning that it shouldn't have been like spawned in yet, then we need to like actually do something. And I guess inversely, what we can do is just say that if it is less than the row size, aka it should already be like determined, you can just return, and then now we like don't have to care about that. So so now we can just assume that like okay, we need to sample and add one to this list. So we can just make a little helper function for the sampling logic because there's some weird logic about like oh sample between -100 plus 100 that you saw in here, and so we'll just implement that here. Spawning an entropy value means selecting rand value plus or minus 100 from the entropy value. So let's first get what the current entropy is. That will be UI state flow dot value dot entropy, like the current entropy. Let's sample something. So you can use random, I think. Yeah, column and dot random. Random dot next int, and then give it like bounds. So you can say current entropy minus 100, current entropy plus 100 to like do this random sampling. Let's see what else it says. Let's make this return an integer in the end. And so, yeah, once you scroll, like after you scroll, it should increase by 1,000. So let's just also do that, where we say that the UI state, we're going to update it to like be the same as before, except the entropy is equal to what it was before plus 1,000. And then we will return the sample that we got. Okay, so that's basically just like the weird entropy logic that we defined or that I defined in the problem. So we can just say now that we sample, and then we have to put it into the list. The weird thing here with like UI state, yeah, the kind of weird thing with UI state is that you can't actually just like mutate this list. Like this is not a mutable list. This is immutable. You can't add or remove elements. So instead of like changing the list, what you actually do is make a new list and then put that new list like in the UI state in the place of what was there before. So I will say like new row equals row or yeah, row dot to mutable list. So we like this dot to mutable list doesn't convert it. It like spawns a new copy of it and returns it as a mutable list. So now you can like add elements to new row. So we'll say new row dot append or dot add. dot add the sample. And then again, you need to actually like replace the old value with this. So we'll do that now. So basically replace the infinite row with the new row. Um, yeah, that should be fine. There's technically also like a to list function, but that should be unnecessary since mutable list like will fit there, and as long as we don't mutate it again, should be fine. Um, and let's see, that might actually be it. I'm not sure if I forgot any logic there. I don't think I did. Let's see actually if that works, at least somewhat. Yeah, because I called on render. Yeah, let's just see if I missed anything. So again, the general idea is that this code is actually not incredibly complicated. Well, yeah, let's see if it works before yap too hard. I mean, oh yeah, it looks pretty good. Um, Something I noticed is that there's those elements are hugging each other. I'm just going to add some padding around this. But you can see here that that code that I wrote wasn't anything too crazy. Like this is pretty basic like Kotlin coding CS stuff. Like this is like really nothing crazy. I just added to a list. And this I was just like sampling random numbers. And all I do to implement like the view model is to just tell the screen, okay, these are the new items that you should show now that you've rendered this list item. So as we scroll, actually I can rerun the app just so it looks a little prettier. But like obviously the general logic here is that as you render these items, the infinite row here will like update to give it the correct like the correct number that it should be showing as you go. And so let's scroll a little bit, and you can see our entry value is going up since this is being called. So entry value is going up, and oops, I did something weird to scroll. But yeah, as I scroll, as long as I don't scroll to the start again, as I scroll, you can see that those new elements are being sampled in and put into this new infinite row, which is then being given to the screen to show these elements. So nothing too crazy, and the logic is actually pretty simple. Um, but like it's only simple because we used MVVM to like separate it into these parts and solve the problem like one by one. So you can see also here that if I scroll backwards, nothing changes. Those are like the old values that they were before because of like this logic that I had here. That's yeah, the point that I really want to drive home, at least with this, is that even though this is like kind of a difficult task, like thinking about it like is a little weird. Certainly from like a Jetpack Compose perspective, separating it into like the UI and the view model makes the state logic actually pretty easy to handle, or at least a lot simpler, where it's really easy to implement a function like this and use it, as well as implement and use a function like that. Okay, let's see. Any questions on that before I try to solve the like challenge version, which is like more or less just doing the same thing 3 times. But any questions on how this works, at least for now, since that seems pretty or that could be like a point of confusion for sure. So any questions about that? I can wait for a few moments for the people online as well. But if we do not have any questions, I suppose I can try to go forward with like the challenge-ish problem as well, and then try to wrap up the explanation as well. But obviously, in terms of my UI state right now, I'm only telling the screen that like, oh, this is the details for like one row. If I wanted to just generalize it, you can look at the hints that I put on here. Uh, but the general idea is that if I have one list of ints representing like one row, uh, this typing gets a little weird. But if I wanted to represent just like an arbitrary number of rows that I wanted to render, I could actually just use like list of int, and this is like infinite rows now, let's say. And so each list within this list is the row. So we can make 3 rows, for example, by saying list of, list of, list of. Um, so it's basically just a collection of like 3 rows, let's say. And so now we'll obviously have to change our logic a little bit. And so when it comes to the row render, like an element scrolled on, we need to get like which row was scrolled on. So we can say like row index as one more parameter. And then the row to get would be row index. New row would be, yeah, let's see, row mutable list. And then let's say that new uh, rows, yeah, sure, whatever, equals whatever this was, or oops, whatever the infinite rows was before. And then we change uh, the row index to this new row that we just made. Basically just like wrapping what we did before in this like uh, arbitrary like infinite rows, like having several of them. And then infinite rows now equals new rows. So now basically it just takes in like which row was scrolled on and then changes like that particular row and then changes the overall like infinite rows. Because again, you can't like mutate the one particular value. You have to make a copy of it. Um, but I mean, that's literally it for the view model. That's that done. And so like that's all the view model logic. Let's hop on over to the UI instead. And so to make this a little easier to work with, we can actually just, here's a tip if you want to make a component really quickly, you can just use this function here, this like little light bulb extract function that'll just like kind of make a function for you. So I can call this infinite row. Technically, this is bad, like passing the view model down, but whatever, this is like interview question. I don't care about best practices. So I need to pass in the row index. So actually, for this infinite row, we'll want to like pass or take in as a parameter like which row this is, because we'll be calling this like several times for like oh row one, row two, row three, and so the row like component should know that in order to call like the row render to like get the right row as well as or to get the right row as well as call and tell the view model that the right row has being like is being scrolled on. And so finally, if we wanted three rows, then all we really have to do is make one that's like row one, row two, row three, or like 0, 1, 2. And I guess if I want to give some space, I could do that. You put some less space between them. And let's see here. So yeah, that should make those three infinite rows, and like they're using the right row indices accordingly. So let's take a look. Okay, yeah, so you can see here that the row is populated. And so now if I scroll on the first one, entry value goes up to something like 40,000. I'm not sure why the emulator sometimes scrolls backwards. That's weird. But now that I'm at 48, when I scroll here, it's still using the same entry value. So you can see here that it starts spawning like 50,000 from that jump here. So you can see like midway through, it started jumping from 17 to like 48 since we were using the previous entry value. And if I go down here, you'll see the same thing where it's about like 20 something, then it'll start sampling at 60,000 now. So using MVVM, the logic here becomes like really not that much to implement that challenge problem or really any parts of this problem. Um, Implementing just like the infinite rows, the logic here is definitely not too crazy, nothing like too like insane, just sort of adding one element to a row at a time. And then again, the UI, apart from those couple tricks that are really nice to have, the launched effect and like the lazy row with the infinite or the max items. And I guess I can show you that this like literally just keeps scrolling like forever. It's uh I wish I didn't have to do this on the emulator. It's kind of annoying. But yeah, like it'll just keep on scrolling. Um you can see if I scroll a little too fast, it like beats the scrolling. So let me back that up. Don't worry about that. I'm sure like edge behavior like that wouldn't matter. Um, but yeah, that's more or less the three sort of infinite rows. And you can see here that with MVVM does not is not too difficult at all to implement and kind of just becomes regular coding in the view model as opposed to like Android coding. But any questions on that as a whole? Or any questions on the like Android interview process in general, anything like that? Any questions? Okay, if not, well, thank you so much for coming. That ended right on time, thankfully. I can uh, splash screen the attendance form. Yeah, One more time, I'll say thank you for taking Intro to Android. This is the last demo, so thanks for tuning in. Hopefully that was nice. Hopefully that gives you a little bit of a glimpse into how the Android job search is. So it says it on the attendance form, but that's all we have. So go forth into the job market and wreak havoc. The world is your oyster. But yeah, that's everything we have. So thank you very much for coming, and have a good night to all of you online. And let us know if you have any questions too.